Hello everyone and welcome to the first topic of calculus, limits. So what are limits? Limits are what the value of y approaches as x approaches a certain number. How do I write limits? Let's say I want to find the limit as x approaches 0 of this function fx. So the limit as x approaches closer and closer to 0 is actually just 0. This is akin to substituting x equals to 0 into fx. However, the concept of limits can be applied to infinity too. For example, the limit as x approaches closer and closer to infinity of fx is actually 0. That's why we call the limiting value, or the value that y approaches, to be equals to 0. That's what limits look like on a graph. Now let's go through a few limit rules before doing some of the questions. If we have the limit as x approaches a of two functions fx plus gx or fx minus gx, this is the same as splitting this into two separate limits, where we have limit of x approaches to a of fx plus minus the limit of x approaches to a of gx. Now this one is about constant multiples. If we have the limit of x approaches to a of k times fx, where k is a constant, this is the same as bringing out the constant outside of the limit. The last rule, which is a really sneaky rule, let's say we have the limit as x approaches to a of fx to the power of n, we can actually bring the power of n to outside the limit. So we have limit of x approaches to a of fx and then whole thing to the power of n. Now, there are three different methods of solving limits. The first one is the most basic, which is just substitution. So over here, we have the limit as x approaches to 2 of x plus 3 over x minus 4. So if we just substitute, this becomes 2 plus 3 over 2 minus 4, which is negative 5 over 2. Simple enough. Let's go to the next one. The limit as x approaches to 2 of x minus 2 times x plus 5 over x squared minus 4. Now, if we just directly substitute this in, what we get is 0 over here and 0 over here. We get a value of 0 over 0, which we know cannot exist. So what I'm first going to do is a bit of factorization. I take the limit as x approaches to 2 of x minus 2, x plus 5, over, and then this is difference of two squares, x minus 2, x plus 2. And you can see over here, I can just cancel out the x minus 2. So this simply becomes the limit as x approaches to 2 of x plus 5 over x plus 2. Which if we just substitute in, we get 7 over 4. On to the next method. The next method is creating quotients. And this is specifically for limits where x approach infinity. So what does that mean? Okay, we can't say we substitute x equals to infinity, but we can say as x approaches infinity, so as x goes to a very large number, this becomes a very large number that is basically infinity. And this also becomes a very large number, which is also basically infinity. So we'll get infinity over infinity, which we don't know how to deal with this yet. So how do we do this then? What it means by creating quotients is getting stuff in the form of this 1 over x. Because as x approaches infinity, we know that this is just 0. Because as x grows larger and larger, 1 over x will get smaller and smaller until 0. So what I want to do is divide by x squared on the top and bottom. And that will get us 1 over x squared square root 3x to the power of 4 plus 7 over, if I divide this by x squared, I should get 1 plus 3 over x squared. So let's write this out. This is just the limit as x approaches infinity of 1 over x squared times this surd, and then we'll have 1 plus 3 over x squared. Now if we put the x squared inside the surd, this actually becomes 1 over x to the power of 4 of this. So I can just simplify the numerator into this. Now if we take the limit as x approaches infinity, we know that when x approaches to infinity, this quotient and this quotient will approach 0. And as such, this just becomes root 3 plus 0 over 1 plus 0, which is just square root 3. The last way that we're going to deal with limits is L'Hopital's rule. Now this rule is very strong. What L'Hopital's rule is if you reach an indeterminate form, and that's 0 over 0 or infinity over infinity, then if you have a limit of x approaches a of fx over gx, this is the same as the limit as x approaches a of f prime x over g prime x. In case you're not familiar with this notation, this is just the derivative of fx and gx respectively. If you're not too familiar with differentiation yet, you can go watch the next video. Now, we see here 0 over 0 or infinity over infinity. Remember, for this question, we have just gotten infinity over infinity if we didn't do anything and just kind of like substituted or like found the limit as x approaches infinity directly. So actually, we could have used L'Hopital's rule for this. For this question, if we just substituted in directly, we would have just gotten 0 over 0, and hence, we could have used L'Hopital's rule for this question too. Now that was just me explaining when we can use L'Hopital's rule. Now let's actually attempt a question. Find the limit as x approaches negative infinity of x to the power of 6 over e to the power of negative 3x. Now the first thing I'm going to do is just use this rule. If you look at this, I can just simplify the limit to this with the cube outside. Now if you just found the limit as x approaches negative infinity, we would have just gotten infinity over infinity. Keep in mind e to the power of infinity is also infinity. And after we reach infinity over infinity, we write this as an indeterminate form. So I can say is we are going to use L'Hopital's rule. And remember, what I'm just doing is differentiating the top and differentiating the bottom, both separately. So if I differentiate the top, I'll get 2x and I'll get negative e to the power of negative x. Now if you just found the limit as x approaches negative infinity, I would get negative infinity on the top. E to the power of negative infinity will be e to the power of infinity, or like a very big number. So we can say that this also approaches infinity on the bottom. And this is an indeterminate form. The sign doesn't matter when it comes to indeterminate form. As long as you have 0 over 0, infinity over infinity, that is okay. Why I use this example is to show that you can use L'Hopital's rule more than once. Since we reach an indeterminate form one more time, we can use L'Hopital's rule and differentiate the top and the bottom. If we differentiate the top, we get 2, and the denominator will get e to the power of negative x. This over here will actually approach infinity, so 2 over a very large number approaches 0. So this is just 0 cubed or just 0. Here's the summary sheet for limits. Again, remember there are 3 different methods of solving limits. Number 1, substitution. Number 2, creating quotients only for limits where x approaches infinity. And third, L'Hopital's rule, only when we reach an indeterminate form for a quotient fx over gx.